Okay, it looks like we're live. So welcome back. I'm going to be continuing to work on the virtual machine. Today, we're going to be finishing the lexer for the assembly, and then we are also going to be implementing the parser. So let's look at what we have right now. So we have a TASM file. So it just has all the keywords in it, just for testing purposes. So if we go ahead and build, and we run the TASM, then here is what we get. So we create a token for each character, or each keyword. So the only thing that we need now, basically, is basically integers. So if we take a look at, if I enter the test.tasm file, so like push, that is going to take that. So we're going to be expecting that always, because you can't push nothing. Let's see. So index dupe, that needs one as well. Index swap. Add does not. Let's see. I'm pretty sure those are the only ones that do. So we need to make sure we can do that. So let us enter the, let's see, tasm lexer.c. So if we go down to the bottom here, yes, so we can actually detect if there's a number. I believe that. I'm not sure why that is there. Alright, let's see. If we run that, it does not work. Custom identifier. Oh, yes. Okay, so I think that is because, let's see. Let me see. Let's actually print the keyword and see what we are getting here. And it is actually a string. And then we'll see what it says right before we do that. H. Okay. So if I open up the TASM file, yeah, so 12. So it's 12. So I think that, let's see. So is it detecting that as is alpha? Alright, let me, see. HH. Okay, so if I print out as a character, well, then it is H. Wait, no, it is not. Alright. Okay, so I'm not sure why that's H. So I think we need to do, for an index stuff, but, well. Yeah, okay. So now it looks like we just, yeah, we do detect when it's a number. So then we need to actually generate the number. So open token equals generate number. And it's going to be fairly similar. And then, so I think we have to do this as well again. And then we'll print the token. Let's actually get rid of that print statement for now. So let's just, we can start by yanking this. So generate, or I mean generate, no. Perhaps it should be integer instead, because it is more specifically an int. Because there's going to be different stuff when we get to floats and such. Okay, so we want, I think we'll store it as a string still. Let's see. Wall is digit. Let's see. So that should be pretty much the same thing. So we're gonna type equals type int. So let's see. So then we do actually have to modify the header file. .h. Let's see. Actually, I will put it probably here. Int. All right, and then now let me go back down here. So let's type int, and we can get rid of that actually. So that should be all that we need to change, really. Yeah, so let's see. Type int not handle. Oh yeah, so we need to modify the switch. That is not switch. So the type int actually goes down here. Type int. Alright, unused variable token. Yeah, alright, that should be okay. So why are we printing this stuff? Let me get rid of any extra print statements. Yeah, not any of these. These are all good. Oops. Alright, yeah, so we don't need that. We do not need that. Alright. So yeah, so type int 12, 12. Alright, so that seems to be working properly. So now we need to add this to a stack properly. So let's actually, we go in here, let us create a struct. And let's see, so we need token, no, we just need a token. And this is the, no, token stack. And then max token stack size. We can define that up at the top probably. Max token stack size, and we'll do 1024 for now. Alright, let's see. So what else do we need? Let's see. So this is going to be called the token. This will be the lexer. And do we need the file name? That might be useful to have. Okay, so then we do need operations for this. So let me actually exit here. And let me create like push stack, or yeah. So I'll actually do that at the top. I think that makes sense. Under the open file. Let's do we don't need to push stack, and we will take the stack. So open stack. Yeah. And then we can do, and also we need the stack size. Let's actually add that here as well. Alright, and so we can basically copy what we have in the in.c. Yeah, push. So it's going to be quite similar to this. So let me just select all this. Right, and then actually, what was that last part? Stack size plus. Whoops. So yeah. And actually, we probably want to return the stack size from this. Maybe not actually. Actually, no. Let's take the lexer for this instead of, yeah, that'll be better. And then yeah, you can modify the lexer directly like this. Max token stack size. Yeah, and we can change this to lexer actually, as well as this. And lexer, and this needs to be token stack. We do need to take a value here as well. And it is a token. Please do that. Okay, so that should be pretty good. And then we can do something quite similar, but for popping. So, all right. To 0. And that is a stack underscore. Let's see. So we can actually, I think we can return lexer token stack minus select stack size. Not sure if that will work. Yeah, we might have to do it like that. Lexer stack size minus, and yeah, we can just do lexer stack size. So let's see if this will compile. All right. Okay, so here, this can return nothing. But then here we actually want to return the token. So here we go. All right. Unused. All right. So it seems to have compiled. So what we want to do is we want to push the token at the end of each iteration. Let's actually start by creating the lexer. Lexer equals that. Okay. Yeah, I think we can do it like that. 0 initialized, and then actually want to set. We want to set the what were the starting parameters basically is what we want to set. So the stack size will start at 0, and then we'll set the file name. Stack size equals 0. I got file name equal. For now, we can just do that, but we will change it once we actually pass the file name. Yeah. And then we want to do push stack. Perhaps it should be push token. I think that would probably be better. And we're gonna pass the lexer as well as the yeah, and this is the same thing. Yeah, so it's not print the token anymore. We do not pass the token to this one. And this is going to be pop token. So let me go up to the top and we'll change this to token instead of stack. Alright, and let's see. Alright, pop token. Oh shoot. Alright, so I do need to change that because we are taking the value, but we do not need a value. Right? Yes. Oh no, we're not actually popping here. Got a little confused. So we do need to pass the token. Yeah. Alright, and we do need to change push token. Or no, we don't need to change. Alright. So we should have that at the end of the iteration. So for in I equals 0, while I is less than lexer stack size I plus plus. And then we can print token lexer token stack I. Alright. So that does not work. Oh, because it is not a pointer. Alright, and let's see. Okay, so it looks like we have all the tokens in here, and they should be in the correct order. So now we can parse this actually. So that's pretty cool. So the parsing is not going to be too complicated. So I will leave that for debug purposes. So let's actually open the Hasm.c. So I did separate this out into a different file. So yeah, because before I had it in the tim.c file, we were running the lexer, but that doesn't make sense because this is just the emulator. So something that we're going to need to do actually is change it so that we have virtual machine is defined in the tim.c file with the tim.h, the header file. And then we're gonna have the assembler, which is this TASM, and then we'll have another one which is the tim emulator, tim interpreter. I'll figure out what exactly to call it, which basically interprets it. So you use that on on the bytecode, and that'll interpret it, and then you use this on the assembly to compile it into the bytecode. So that's the idea. So yeah, so now we're going to need a parser. So let's include actually this is defined in tasm.h. So tasm parser.h. So we'll have to make that. Let's also include team.h in there instead of in here. Yes. So let me just touch the file. So we need tasm parser.c and tasm parser.h. So we should have tasm parser. Alright, let me open both of them. Alright, so let's do parser. And we will just print parser. I can spell. Yeah. And then in here, define. Let's see, parser. Still cannot spell. Parser h, then define it. And then end it. And let's include fdio.h. Yeah. So now if we run the build, we do actually have to include it into the build.sh. So right in here, tasm parser.c. Alright. And let's go ahead and build this. Okay. So parser. So I think I need to actually take this and put it into the header file like so. And let's see. Alright, still, oh, I didn't actually include it. We should do that. That is in here. I didn't include it. Alright, I'm not sure. Parser. Seem to have messed something up. Let's actually, let me comment this out, because that is causing problems. Because I need to change that up a bit. So let's see. Yes, we need stdio. We do have that though. So, oh, you know, we don't include that in here. We need to include that. Tasm parser.h. Alright, now it should work. Yeah, so we didn't return, but that's okay. So yeah, we can return 0. So we're not going to be returning an int actually. So we are going to change that. But so I think we can just use a linked list instead of a tree structure for the parsing. Yeah, since it is pretty simple assembly, it's not like, doesn't have all the complexities of a higher level language. So we can probably do something like this. So we are going to actually use that token. So let's include tasm lexer.h. Yeah, so we're gonna want that. So token, that is going to be the value. And then we are going to have, let's see, this can be called let's see, so what would we call this? So this is the list. Basically parse list. Okay, so then we'll have a struct parse list next. So then we'll basically set the value and then have the next one. And basically then we'll just check. Basically we're going to be checking the grammar of the assembly, and then we're going to be setting it into the parse list. Yeah, so in the parser, we are going to need to take the token stack, or actually we'll take the lexer. Yeah, and that should probably be all that we need. Yeah. So let's make sure that works actually. So if we go into the lexer file, Let me change this to lexer. Then we can return the lexer at the end. And then in the tasm.c file, we can do lexer equals lexer and pass the lexer there. So now we build this. We use parameter. Yes. Alright, so that's an issue. We need to change the header file. Whoops. No, this is actually this is going to be returning a parts list, so we can change it to reflect that. But then in here we need to change it in the tasm.h file. Or no, tasm parser dot tasm lexer.h. This one. That is the one that I want. So yeah, this will return a lexer. Alright, yeah, so that is something that we need to change. Oh, okay, so we can't actually call that lexer. We'll call it lex. And we'll return lex, and then we can go here, call it lex. We can call it, I think we can call it lexer in here. I think that should be fine. Alright, yes, we need to change this now, anywhere we have lexer. So, yeah. Just lex. Yes, indeed. Lex, okay. And now we seem to have fixed all of those problems. So now we should have access to this. So let's create the parse list. Yeah, we'll call it that. We'll return list at the end. We'll initialize it with 0 for now. Alright, so what do we need? So we need the value of each token and then the next. So we'll actually start it with next equals null. So we need some operations to be able to append to the list. So yeah, we need to void append, and we'll take a parse list as well as a token value. So what we have to do, so we start at the list, which is the root. Actually, I think I want this to be root. And then, yeah, so this can be head. And then we're gonna traverse through. So while head next does not equal null, then we'll do head equals head next. And then at the end, the next is null, so we'll set head.next equal to the head value equal to value. And then we need to actually, yeah, so we want to do this. So we'll create a new parse list. Let's see, so what will this new one be called? Let's call it new. New equals mount size of parse list. And then we'll set new.value equals value, and then head next equals new. And that should change it in the structure. Yeah, so now if we append, let's see, let's do for int I equals 0, I is less than lexer, let's see, stack size I++, and then we'll do append to root, and we'll pass lexer dot let's see, lexer dot stack token stack I. And then we want to actually do while root does not equal null. Then we'll do root equals root next. And we'll just print the value. Print token root dot value. Alright, so let's try that. Let's see. So list is, yeah, because it's called root now. This needs to be dot. Let's see. So this needs to be a pointer actually. No, it doesn't, because we can do stuff like that. If I can get it right. Right. So let's actually do print list. And we'll do this instead. So while head does not equal null, then we will do print token head.value. Head value. And yeah, we won't return anything. And then what we can do is we can get rid of that. We can just do print list, and we'll pass the root, and we do not need a token value. Alright, we need to reference that. Let's see, or I mean reference that. Print token. So it does not recognize that. So did I not include that? I did. Types in lexer.h, and that it should. Oh, I don't think I defined it in here actually. Yeah, let's actually go ahead and define anything that we are going to use, which is probably this one. That would be useful to have. As well as, whoops, as well as this one up here, print token. Alright, and now, right here, okay, we need stdlib. So let me actually do that, include stdlib.h. Alright, and let's see. Next. Alright, that is here. Okay, so it is that. Let's modify this. I think we can do something like this. Alright, that does not work. Does not like that. I forget the syntax. Something like this. No. What's this? I always struggle with this. Oh. Okay, yeah. So then we segmentation fault. So we reach halt. Let's see. That is the last one. So we do go past the last one. Alright, so why are we seg faulting? Yeah, it is in the Actually, is it from? Let's just comment that out. Yeah, so that is actually happening in here, where we are printing it. Let's see. Yeah, so it doesn't happen here, but it wasn't happening before. I do not believe. But let's go back into the parser. Let's do that. And it goes forever. Oh, we don't actually do head equals head.net. Head.net. That is quite important to do. Alright, so this actually lets us print it all. So now we have all the tokens in the stack. So we don't want to just do that though. So what we want to do is let's see. So we will let's see. So generate list, and we are going to take a parse list root, and then we will take the lexer. So then instead of doing this stuff, we'll still print the list, but we will generate list, and we'll pass the root and then the lexer. Alright, yeah, and let's make that a pointer. There we go. So basically what we want to do is we want to check all the different possibilities of the token. So I think we can do that. Let's see, we have this in here. So basically we're going to be doing the same thing. We're not going to be printing it. So we could actually return the token type as well. Do we need to do that actually? No, I think we need to just copy this. Alright, we'll just grab that. And we'll indent all this. And we do need the closing parentheses. I can do that. There we go. Okay, so we don't want to print it, but so we'll do while while lexer token stack size does not equal 0, then we're gonna need this switch in. So let's actually make this. We'll indent this. And we need one more closing plate. Okay. So, and then we'll do, we'll do token stack size -1 lexer. Right, and if we build that, we have some problems. It is just that size actually. Did I do that up here? Yes. Alright, unused parameter root, that's okay. Token undeclared. Yeah. So lexer stack, and then thank you for following. I'm not sure exactly how to say your name, so I'm not gonna try and then mess it up. But yes, thank you for following. I appreciate that. So yeah, we want stack token stack, and then 0. So actually, yes, that's how we want to iterate through it. So while index equals 0, and while index is less than, my screen is orange now, token or lexer stack size. There we go. That is what we want. So we don't want to actually decrement that. Then, yeah, we can go through each one. So, alright, and let's see. Pipe push. So yeah, we don't actually iterate the index. We should probably use a for loop instead. For in, yeah, we'll call it index. Then we'll do index plus plus. And I put 5. Alright, and if we run that now, there we go. So we need to do -1. No. Alright, that is actually not right. This needs to be set to index. Okay, yeah, so it still does that. So I'm not sure what this extra one is. Oh, that's something else that we're printing, actually. Yeah. So that's what that is unrelated, actually. So yeah, nothing wrong with that. So now we can iterate through them. And basically want to check. So if it is this, if it is nope, then let's see. So if it's none, we don't, when do we say something is none? Yeah, so we don't, if it's none, then we have a problem. So it shouldn't be. So I think we can assert this. Assert false, and it should not be none. Alright, yeah. Alright, so then if it is nope, that is a valid token. So we will set lexer, no, not lexer, root, will append to root, and we will do lexer token stack index. And then, yeah, so we can actually do that for all the rest of these. Oops, and I messed that up. It's just the same thing. Okay, so, but then depending on certain things, we need to check what the next token is. So let's get rid of the printf statements, actually. I could make like a macro for this, but I don't remember how to do that, so. Alright, that should be appending it. So if we actually run that, oh yes. So let's actually, we need to include assert. And we'll include std bool, sure. You know, we could just do 1, but, or I mean, 0? I think 0 is false, yeah. So yeah, now these are all appended to it. Yeah. So now we just need to check check the next token and then append it accordingly. So let's actually do index plus plus. Actually, not so just on push. Index plus plus. If token stack index dot type does not equal type int, then we have a problem. So we will fprint f be there error token expected type int but down whatever we found. So let's see, that is that index dot type. Yeah, so actually we're not gonna be able to do that because we don't have, I'll need to implement that actually. to do deployment token. Yeah, so that is what we found. And then we'll exit with that. Okay, and I think we can do the same thing with this, because that is what we want, as well as this one. I think those are the only ones. So then, if we find it, then we want to append it. And the same thing here and down here. And then I think that is pretty much it. So let's see, we have some problems. Token stack. Yes. That is a problem. We need to do lexer token stack. Yeah. Lexer token stack. And down here as well. Okay, so if we build it now, we run it. Yeah. So we want to. Alright, so let's actually test it. So if we go into here and we do not have that, the next token would be push. So now if we run it, expected int, but found that. Yeah. So that is what we wanted. And that's basically. Oh, yo, what's up, man? How are you doing? Yeah, that's basically exactly what we wanted. Yeah, and we'll just change the values a little. Yeah, so now we have the list of tokens implemented. I am doing quite well. So now we can, I think we're ready to generate actually. So if we, let's see. Let's actually add this, let's see. Print list. Let's add this into here. And then if we go down here, we'll get rid of it from there. Generate list and return that. And then in here, we can do parse list, parser equal, or list equals that. And then we can print list, list. Alright, so let's see if we can build that and then run it. And it works all the same. So we now have the tokenization or lexing and the parsing complete. So we are ready to do code generation, or bytecode generation. So let's see, I'm going to close some of these extra files that we don't need at the moment. We do need that one. Shouldn't need that right now. And I can always reopen it, so it's not a big deal. I don't need that. I need this one or this one. Okay, so in here we have write program to file. So actually, yeah. So basically we need to convert this into instructions. So basically into stuff like this. This is how it's going to look. So we are going to make a list of instructions. Yeah, so let me make, I could probably do it in here. I think this is a fine place to do that. So let's do, I don't think we need a stuff actually. So we need the list of instructions. So we'll do instruction program, and we'll do, and that should be defined in the tim.h file. All right, maybe it should be dynamically allocated. Now I'm thinking about it. Perhaps that would be better. Let's see. So I think we can do it something like that. Array size missing. All right. Let's actually do max program. So we'll just find it up here for now. And that should work. Yeah. So we can do that. Okay. So it's still unused. So now we want to generate instructions, and it's not Python, so I don't know why I did that. And we will return the list, and we will take in let's see. Yeah, so we'll take the parts list. And that should be all that we need, actually. This thing, we'll call it head, because we're going to be iterating through it like a linked list. So we shouldn't need that right now. So we are going, so I think we can actually define this in here. So that'll be the program. And then we can do wall head not equal no. Head equals head next. So what we want to do is another switch statement, and generate the according things. So actually that is in here, this one. So if we yank that, and then yeah. So we have this lexer. Alright, so this is not what we want to switch. We want to do head we don't need that. Head token head value dot type. Okay. So then we do not want to append anything. Let's get rid of every one of these appends. Because we don't need those. Almost there. All right. So now we have all those. So yeah. So this should not ever be none. Yeah. All the rest of the tokens are valid though. So what we want to do is, let's see. So we want to set the program to be like this, and we have all the macros defined in here. Yeah, so we can use these same macros in there. So basically, this needs to be appended to this list. So let's do program size. We'll start at 0. So then we'll do program size equals that. So that should work. Yeah. So we just need to, change the value for each one. So like this will be push, and then we also need the next value in the list. So we'll do head equals head next, and then we will do program size plus plus, and we'll set it to, let's see, we want to set it to, yeah, so that's not what we're going to do actually. So we want to get the value of the next one. So we don't need to do that. Yeah, so we'll do, we want to convert it to integer. Let's see, program, yeah, head value, so that is a token. So what is, how does the token define? By opening up the token. Parser.h. So the token has, let's see, nope, this is not what I want. I wanted lexer.h. So yeah, it has just the text. So that is what we want from it. Dot text. Let's see. So that should work, I think. Yeah. Okay. So let's do that. Let's see. Yeah. So that is what we wanted actually. So then this can be pop. Let's see, dupe, and then this is index dupe. Yeah. So index dupe needs to be actually basically the same as this. Except instead of this, it is in the swap. And we can get rid of this one. And this one is index dupe. So same thing as that. Yeah. So I'm quite sure this should work. So now we have add, sub, multiply, and divide, and mod. Add, sub, multiply, divide, and mod. Alright, and yeah, we just need to do this for all the rest of these. Alright, this is halt. So we shouldn't actually encounter this. So this should be asserted because we should only handle it on the other. So error false and error should not be in. We can make that better later, but we shouldn't ever encounter that. So that's the point. Yeah, so that was right actually. Z jump, regular jump, couple, compy, couple again without the E and G, compare not equal, compare equal, and there we go. So let's actually try to build this now. Okay, control reaches N. Alright, so we need to return the program. Return program. Alright, unused variable list. So that is in function main. Alright, returns the address of a local variable. Okay, yeah, so we need to let's see, how do we want to do this? We'll get back to that. So we have an error. It looks like I must have messed something up in here, perhaps? Or I mean in, let's see. Yeah, it is in here. So did I remove a semicolon or something? Doesn't look like it. So this should be working. Okay, let's see. That is in here. Yeah, down here it says on your variable list. So let's actually generate. Whoops, put that in the wrong place. Generate instructions from the list. Okay, and let's see. So let's actually do instruction program, max program size. It's that. And we'll pass that in here. And then we can get rid of that. Alright, control, which is end of non-void function. Okay, so which one is that? Tasm.c. We are returning it. I don't think we need to return anything actually. Let's make this. Oh shoot. The problem is that we did not do this. We need to change this. Alright. So we need to do that. Alright. Yeah, so that's not going to work actually. So we need to pass this like that. Whoops, and I just closed the window. Yeah, so let me exit that and then open it back up. In here. Alright, expected ins. Yeah, so we need to do that. Alright, that's something. So that. Alright, so the macro expansion did not work. So we need to change that. So we can't just set it like that. So let's see. So if we were doing this, that should work, right? Mm-hmm. Expect. So doesn't like that. All right, let's see. Mm-hmm. So let's actually do something to append it. So did append to program, and we'll do, let's see, we need program size. And I need to include this. No, we don't need that one next. We do need the type though. So then instruction type. Then we can do that's not gonna change anything. So how do we set that? Trying to think. So it doesn't like that. Mm-hmm. Mm. All right, so what am I supposed to do for this? So how do you set append to array of struct? I don't remember how to do it. Uh-huh. So do we have to create the instruction first? Instruction equals install. All right. I spelled it wrong. All right, so that seems to work better. Yeah. So we'll do this. And we'll start it at 0. And then we'll just change the value and then append it. So like that. Alright. No, so that doesn't work. Alright, well, let's just do that for all these things. Because that works. I will look into it later. That's a cleaner way to do this. We don't want it to be Hulk, though. It's not typed though. It is inst jump. Inst jump. Which I am going to change that from print, because it should not be that. NZ jump. Oops. Regular jump. Alright, okay. Citing content. There, here. Actually, this is fine. Alright, not equal. And this is equal. Alright, we are getting there. And it will be different once we get to the other ones that take a value. That's not sub, that's multiply. Multiply, there we go. Alright, yeah, so for this one, we need to do it a little different. And then, let's see, dot value equals get value dot text. Alright, I think that should work. Okay, yeah, so this is just regular swap. Don't need all that. And then for regular dupe, it is the same. For this one though, we need to do that. And change this to movie. And it's the same thing for push as well. Except it is push. And then, yeah, so we have this. Goes right there. Pop, and then last one. No. Okay, and now let's see. Alright, so that doesn't work. Yeah, that's what I was thinking would happen, but it doesn't let me change it. So, So let's do that is on line 113. Let's do 8 to 113. We replace inst with no. Okay, and that would be like that space. But this doesn't work. Yeah, so it doesn't let us set it like that. So actually, I think we can just do like that. So that's what we're supposed to do, actually, right? Yeah, because we're not setting it. So that is what we need to do. Okay. I don't really want to go back and change it all now, but yeah, I have to do that. I forgot that that's how you do it. Yeah. Let's see, maybe I can do something like, and change it to dot type equals that. There we go. That should work now. Might have messed up somewhere else though. So yeah, let's see, instruction 0. Did I remove a semicolon? It looks like there is one missing. Oh, here's the problem. We need to get rid of this. Okay, pretty easy. Here as well. Here, here, here. Okay, and then there's a few more down here that I went past. Alright, and now, alright, and then, oh yeah, we need to change it up here. Alright, instruction dot value equals head value dot text. Okay, and we can get rid of all this. And this shouldn't be add, actually, this should be in swap. And I will fix that indentation issue. Just give me a moment. Okay. We have put one more. Oops. One more right here. Oops. That is not what I want. Okay. So now, for real, it should work. Okay. We run it. No errors. Let me fix that issue. Okay. So 2.1.13. We'll do. Shoot, that's gonna mess up that as well. Instruction.type, and we'll replace it with instruction.type. Okay. That did mess up this one and this one that I already fixed, but there we go. So I kill it again. Alright, so now let's do program. Let's try to execute the program. Execute program. Let's see, what is that actually? So in here, do I have it defined? Write program to file. Let's see. Can I run instructions actually? Run instructions. You need a machine to that. So let's write the program to the file then. So write program to file, and we need to pass the program. What else do we need to pass? So we need the machine. So I need to actually change that so it doesn't take the machine. And we'll do test.in right now. But yeah, so we need to modify this. Write program to file. We want to just take the instructions. Or actually, I could probably just define a machine pretty easily. What is the machine? So that it has the instructions, the program size. Yeah, so let's actually just do that. So yeah, machine equals, so let's see, we need program equals program, and then program size equals, so I think we can do size of program divided by size of program 0, and that should be all that we need. And then we can just pass this machine. We need to actually yeah, forgot to semicolon. Yeah, so we need to do that. And we have some more problems. Missing braces around initialize. Let me see. Instructions, that's what it's called. Alright, and now Okay, and let's do that. And let's look at, let's see, did it make 10? All right, semicolon. Is that all that it did? No, okay, so it looks like that is probably our bytecode. So let's try to hex dump. Let's try 10. Okay, so now let's actually go into the, as an FC, yeah, right here. So now let's read program from file. And let's see. So what do we actually hang on, let me go here. Let's actually try to just run the instructions. After we generate, instead of writing it to a file right now, we'll do this. Run instructions. And yeah, we can just pass the machine. We don't need to define it though, and we need to do that. All right, let's do that. Stack underflow. Okay, so it didn't work. Actually, that's probably. Let's see. So let's give it all that. Let's push 5. Let's do that. All right, and we do want to print the stack when we're done, though. Let's see. So do we have a function for that? I believe print stack. Yeah. Let's print the stack of the machine. All right, and it. Oh shoot! I think it worked actually. Oh my! All right, push 10. Okay, and then if we add, should add them together. 15. Okay, so I think, yeah, instead of printing, we could just do that. Print, and it should print the topmost element. Yeah, so it printed 10, and then we have 5 left on the stack. So we should be able to swap as well. Swap. Yeah, so it swapped. So it seems to be working. And we should be able to pop. Okay, so we have working assembly now for a virtual machine, and we should get an error for that. We can make the error handling better because we need to check. Yeah, we need to check. So let's actually let me separate some stuff out. So let me make the emulator actually. Let's see, is that what I'm going to call it? So let me touch. Let's see. So Tim emulator. That's probably good. Time. Yeah. Okay. So that's what we call it. So time.c. Time.h. And let's open time.c, and then we'll do so. Yeah, we want a main, and we'll basically just read from file. So let me open time.h. Actually, time, is it gonna mess? No, it should be fine because yeah, that should be fine. So might get confusing, but that's okay. So not fine. I might change it with time h. And fine h, and then end it. Let's include h, and then we'll include tim.h, because we want to be able to so we want to read from file and then run the instructions. So read program from file. So in here, read program from file. Yeah, so the file path. So let's do that for now, but then we'll make it you can take the argument. So let's actually create a machine. And yeah, it'll be, oops. It's that to start. And yeah, we will pass that. And then we can run instructions from the machine. And yeah, so that should be pretty much everything that we need there. So let's actually, in the build.sh, let's do this. So this will be Tim E. Time. Yeah, so we need that, and we need time.c. So let's actually try to build that. Right. So that doesn't work. Because we need to actually include .h right here. And there we go. So now we should have time that should run the instructions. And it did not. Oops, I meant to do that. Okay. So test.tim. Yeah, so I think let's see. So I think we do need to modify this actually. The read program from file. So we want this to actually be size of instructions divided by size of instructions 0. So I think that is what we want. No, actually I think we want to do that here instead. Size of instructions by size of instructions 0. Okay, so let's see if that makes anything better. Alright, so let's run time. Alright, so let me go here. Let's see. This one. We're not writing it anymore. So that could actually be the problem. Yeah, so I need to change it back to be working. Alright, and then we can run time. That doesn't execute it. Let's get rid of that. Okay, so that's what we want in there. And that. So I think there's a problem in the read from file. Which we need to change. No, that should be fine. So let's make sure we are getting here. So what? Alright, so that is working. Should we close the file? Let's actually print what the program size is. Right. It's machine program size. Right, and it is a zoo. Alright, and it doesn't print anything. Okay. Yeah, so that doesn't work. So if we go back to this, which isn't right, but then it still isn't printing. So length. Can we print the path? Alright, so that is working. Program size. Alright, so why is the length 0? Or non-existent? So now it doesn't print anything, so it doesn't make it. Oh no, I'm running wrong code. Okay. So it does recognize that. Alright, so that does work as well. Oh, because we're setting it to that. So if we do size of instructions divided by size of instructions 0, then that is 1. So I don't think it's 1. 1 is not right. Let's see. Let's print that as well. Program size. And okay. Alright, so well, I don't think we need any of this anymore. So let me just comment that out. Because I don't think I'm calling it from anywhere, but it would be interesting. Alright, right, do we need to actually do that? Oh, we need std lib. Okay, so it still doesn't work. Machine program size. Does it change? Does indeed. So why is it not working? Oh shoot, you know what? It probably is working, right? I'm just not thinking. Maybe it's not. Let's print the stack at the end. Let's see, time.c. Okay, so it is running. Yeah, I'm just a stupid person. Okay. Yeah, so we do not, let's see. Yeah, so now we should be able to compile it and then run it. So if we modify it in here, push 15, push 20, and then we add, let's see, and then we swap. Let's see, is there anything to swap? It's gonna be 35, yeah, so it should be 35 is on the bottom. So let's run that, and then we run time, and there we go. So stack, and so what, we don't want to run the instructions actually in here. Yeah, so we have 5 on top and 35 there. So let me build it again. Because we don't, yeah, there we go. And now it should work. So, and then we can swap again, and it would be the opposite of that. Yes, indeed. So now we have assembly for our virtual machine, which we can compile using this, and then we can also execute it using the emulator. So that's pretty cool. Yes, indeed. So I'm not very good at, like, I'm not used to working with stack-based stuff like this, so I might not be able to make anything that cool, but let's try to make something fairly simple. So we have a good few instructions. Let's see. I can close most of these. Let's see. Actually, let me open up .h, because that is where our instructions are. So we have nope. Let's actually test to make sure that works. Nope, and it should just ignore it. Yes. Okay. And let's make sure we can jump. Let's just jump to 0, and that will probably. Whoops. And that should make an infinite loop. Yes. Okay. So I need to modify jump actually. That is the problem. Yeah. I messed that up. So that is in the asm.c. So on the jump, yeah, all of these need an index. No, just this one needs an index actually. Yeah. So no, they all need an index. I don't know why. All right, so let's just actually, we need to do this same thing for each one of the jumps. Oops. All right. Yeah, I forgot that those use an index. Nope, I can't get it right. Now it's not gonna work. Okay. All right. We don't need it for print, so I don't know why I'm doing it. All right. So this is nz jump, and yeah, we can just do that. So we just need to change this to be the correct values. There we go. So that should be all that we need to do. Let's build it now. Let's actually go into this one. No. This one. And we'll build it. And we'll run it. And there we go. And okay, dot. Do an infinite loop. Okay. Well, so that's not good. So all right, well, we don't want to do that actually. Got to remove some stuff. Yeah, that should be working. All right, there we go. So Stack Overflow. All right, let's try to print on each iteration, and we'll see what happens. Print. And it. All right. Let's see. Yeah. So it. Huh. That is interesting behavior. Let's push 5 and then jump 0, and it should. So it does Stack Overflow. Yes, okay, infinite loop. That's what I wanted to see. So that is working. I'm not sure why it wouldn't be working. But then if we push 10, yeah. Okay, so it is still an infinite loop. Yeah. We can add. So something that we need now is labels. So that would be important. So you could do, like main, and that's all indented. Right now this won't work though. But yeah, you could do something like that. And yeah, so custom identifiers are not implemented yet. So we know where that's going to be. That's where we're going to implement it. We're going to set this as a label. And then we need to know what, like, so if we have like main there, and then we have jump main, right? To start at main. Well, so first we need to change this to an index, right? So it'd be 0, 1, 2. So it would be set to the 2 index. We need that. So we need to scan through it first, basically. Get whatever the value of the of the labels are, and then set it equal to that. So like it's the line number. Line number -1. Yeah, so that's something that we need to do. Yeah, we need comments as well. I think I'm gonna do that kind of comment. But let's see. So this is all working infinitely. So we can try to make something. Let's just do like Fibonacci in a second. I mean, kinda. I might be able. Let's see. So let's try to implement this. Because that'd be pretty cool. So let's actually do iterative Fibonacci. I can't spell. Yeah, because I want. Let's see. I've looked at this before. Yeah. So we need to do something like this. So we need. Let's see. So we need to push all of the values onto the stack. 0. Yeah. So those are the 3 that we'll have. So that's the previous number. The previous is the previous, and this is the current number. Yeah. So then we need to set. Okay, so we need to try to think about how I would go about doing this. So I'm gonna use comments, but it's not gonna work. So something like this is current, this is prev, this is prev, right? Something like that. So current is at the top of the stack. We need to we need to do undo. Let's see. 1, and then we need to, so that would be at the top. Then we need to in swap 0, because then that would do that, and then we need to pop. So then basically what that would do, it would duplicate this one, right? So then that would be at the top, and then it would swap it with this one. Right now it's 0, so it doesn't matter, but it would swap it with that one, and then we pop that one off. So that should be basically equivalent to that, and then previous number should be equal to current number. So yeah, so we need to do basically the same thing, but you do 2 and swap 1 and then pop. And then current number equals previous number. Okay. So then we need to, yeah, we need to add them together. So maybe at the top. So you can undo 0 and undo 1, add. So that would be at the top. And then we can swap 2. And that should set that. But then we need to, let's see, then I think we can pop. And then let's try jumping to 0, 1, 2, 3, 4, 2, 3. Alright, let's see. Alright. So something is not right. Use the, oh yeah. Alright, let's see. Should not be int. Okay, so let's look at where that is at. Chasm. Should not be int. Yeah, so we are not doing something correct. This needs to be index swap. There we go. Okay, now let's run it. Alright, so it's not continuously run. Let me get rid of, I don't know, I mean, these shouldn't be interfering with it, but okay, so it's not an infinite loop. That should just, so why does it not loop infinitely with this? Let me open, let's see. And then this is where we are executing it. We can get rid of that. Okay. So machine, all right, nope, it's continue. So push. So let's see. Can we print the stack on each iteration? Could we do something like that? I don't want to go right there. All right, yeah. So print stack machine. All right, let me try that. All right, so it does many iterations. It does a couple of iterations at least. Yeah, because it's each one. Yeah, but it should go forever. So jump to 0. So why does that not work? So let's actually print the machine on each jump. Print stack machine. So, all right, and let's actually get rid of it in down here, I think. No, it is in this one. I'm not C. All right, run off that. So run instructions. It must not be recognizing jump. All right, I think it's because the program size is not good enough. Because I messed it up. So that is in here. Up here. So let's set this to So why are they always the same? Why are the instruction size always the same? Because this should be the same. This one, the program size. But this should be variable. Alright, let me quickly, this is gonna make it easier. I will add let's see, so into this one, in argc argv, like that. Okay, and then so if argc is less than 2, then okay, usage s, let's see, and then we need file name dot tip, and we want to put rb1. Otherwise, we want to do error file name equals rb2, no, rb1, and then this is 0. Yeah, and then we will pass that in here. Or we'll pass that file name, not that, file name, and then we need to do the same thing in asm.c. So we want to c, and then enter argv, and if argc is less than 2, then same thing. Usage is file name. Yeah, so file name dot. Okay, and we'll exit 1, and then we do file name equals rb1. And I forgot that we need to provide this. 0, and we need to pass, let's see, so it is in the lexer. We'll pass the file name. Now we have to open up the lexer. No, we need the .c file. C. And we need to change this to take file name. And this will be file name. Okay, so now build this, and then I run Python. Then yeah, we can do test.python. Okay, and it's always gonna output actually, I guess, as the same. So we do need to change that. And that that one takes test.python. Okay, so now it is different. It's not working though, but let's see. Tasm.c. No. Tim.c. Let's see. Stop. I don't want that one. I want Tim. Yeah, so it is not Tim. So that is. So is it not writing to the correct place? In. Yeah. Okay. In. Let's see. Which one is it? It's gonna be the in here. Yeah. So we want to write to the file name as well. Alright. Yeah. We need to just call it that one. Yeah. Machine.pin. That's what we'll call it. We will rebuild. And then now we have machine.tim. And it's still 7. And it doesn't work. Test.tim. No, machine.tim. Alright, and then it jumps forever. So, did the wrong file. So what does that do? Alright, so that, yeah, it does not work. So, yeah, we're going to jump to 1. And let's get rid of this jump and let's see what happens. Alright, and it goes forever. So are the indexes messed up? That could be the problem. We change that to 2, then it works fine, right? But now it's just jumping to itself. Yeah, okay. So if we do jump 2, then right, so it still doesn't work. If we do, oops, if we do print data machine. So let's go into the this one, and let's print all of the tokens that we get from this. lex dot stack size. So let's print token lex dot token stack stack lex dot stack size. Alright, let's try that. Alright, that's right, has it. Alright, so yeah. So that doesn't work. Doesn't work at all actually. Oh yeah, we didn't. Yeah, so we want this to be I. Alright, so it's segmentation false. So we must go too far. Why does it become no? Yeah. Alright, so there is definitely a problem with this. That's not good. Alright, so it could be with how we are setting the stack size. Stack size. Yeah, so here we actually have the same thing that we did. But, so the stack size starts with 0. So let's see. In the push, so I could be doing this. Let's see. Do I want to do that first? Let's print the stack size. Stack size. Right there. 26. Okay, so right, that is 15, 16, 17, 18, 19, 20, 21. So that should be right, 26. So that should be good. So we start with push, so that's right. Okay, so it's not like an out of bounds thing. So we have a different in the print token. Let's see, print token. Let's indent this. I think we need like a default in here. And then we do insert false. Let's see if that triggers. Alright, and we need to include that. So in here, we can also include the bool.h, and we'll include assert. Right, there we go. Alright. So it still happens. Let's actually do if token equals null, then we will assert false, and actually we can just assert that. Assert token is not equal null, and error token cannot be null. Alright, let's try that. Okay. Yeah, that one. Alright. So it still does that. Hmm. Let's see. So that, that's not equals that. Um, so we didn't get any errors with that. Hmm. So let's see. All right, so we do actually exit that. So is print token like consuming it? No, it shouldn't be. Hmm. Let's see, dot. Dot. Okay, so hmm. So that is a problem actually, because we can't. It needs to start at 0. So let me. That is in the Which one is that in? Let's see. It's in the lexer, yeah. So when we are appending it, in the push actually, in the push, um, Alright, so that should make it a little better. Now we can print 0. Uh-huh. So that is the right index now, but it is still... It only segfaults when we print the value. No, now it segfaults every time, so that's not good. But there it does. Mm-hmm. Okay. So it segfaults if we print something. Uh-huh. So it is in the list, or in the parser, where it does that actually. Let's open up the parser. Let's see. So we are generating the list. Right, let's see that. Alright, so we do go there, and then obviously it's gonna be after that. Yeah, so it is. Perhaps we need a debug in here as well. Insert false and unreachable. Alright, so that is not where it is at. Alright, let's actually null. It cannot equal null. Alright, that's not what the problem is. Let's print the stack size as well as the index. Identity of the action. No, it just needs to be D. Okay, 26 and 0, and then it stops working. So so we only get through the first iteration. So why is that? So that should be in here. Push. So we get a push, and then it breaks. We can say index. That doesn't work. Then if we don't print here, then it works fine. No, doesn't anymore. So let's get rid of all this actually. So it still breaks. We need to do -1. So why does it segfault here? So is it there? No, so it makes it there. Right, so it doesn't make it there. So it doesn't. So it's in the append. Where in here? Right, so it is not there. I'm assuming it. Right, so head next cannot equal new. That's where it breaks. No, so we make it there. So what? Hmm. Hmm. Okay. We make it to this point, and then it segfaults. Hmm. So why is that? Hmm. Wait, so why is it printing here before push? Okay. Oh, because we are appending up here. That is right. Yeah, okay. That's not the... That's not right. Yeah. So we should see 2 here. So if we do that, we should. Here, push here. Okay. So there's a problem with our append or insert is what it really should be called. So it is here where that happens. Okay. Okay, so we shouldn't be going through that many. You know what the problem is? Oh my gosh, I think I realized that. I think we can do that. we need to do new next equals no. There we go. Yes. Okay, now let's see. All right, so it's still, let's see, it's not executing. But I believe it is working now. So yeah, so that looks right to me. Here, here. Yep. Okay, so that seems to be working now. So that was the problem. Yes, indeed. So let me get rid of some of this stuff. Okay. Okay, and then now let's see. So that still doesn't work. Let's see. In the time.c, let's print stack of machine. So 5 and 1. Alright, so it works when we do that. Uh-huh. But if we don't make that, then it doesn't work. Shoot, I didn't actually build it. Lutfisk, if I'm pronouncing that correctly, followed. Thank you very much. I appreciate that. Alright, so let's try that again. Let's see. Okay, yeah, so then it doesn't work. So that is quite strange. But now it'll work. If I do it again, it works. So let's see, in the, which one is it? 10.c. So we are printing, I want to keep that for now. In here though, we should be printing the stack. Okay, I must have, oh, only on the jump though, that's right. So yeah. So we jump. Alright, and it breaks. Okay, and it doesn't break there. So that is a problem. And that goes forever. And alright, jump to one next. Still goes forever. That is not right. Alright, that doesn't go forever. So that everything's interesting. Okay. So yeah, so this index is not right. So we need to, let's see, so that should be, so we need to add 1 to it, I think. Or we need to, what do we need to do? So when it is 1, it is jumping to itself. We don't want that. So we want, well, here, in, let's see, in here, on the jump, we don't want to subtract 1. Let me just make sure that works. Test.tasm. Okay, so yeah, that's more like what we want. Whoops. Alright, so that should work now. So we can jump to 1. Can we jump to 0 from here? So that's seg faults. So that is in TASM. Alright, so we make it to there. So it's in the generate instructions. Alright, let me try that. 2, 3. Okay. So we aren't jumping to 0. Uh-huh. So the jump doesn't seem to be working properly. Alright, and that seg faults. That's not good. Dang, there seems to be quite a few problems. Right, let's see. This should work. It does not work. Okay. Alright, yeah, so that is with, let's see. So this needs to, this can't be that. Yeah, and then it works. And it works how it's supposed to. So there is a problem in the parser, it must be, with the jump. Let's see, price is head. Is this with okay. Yeah. Alright, let's see. Okay, so we're printing the stack. But when we don't print the stack, it doesn't print anything. It does print. Alright, it prints 7, yeah. Wait, no. Alright, so it's not actually printing anything because, yeah, it's... Okay, so it's not printing. So there's a problem in our print. Instruction print. So are we not, we must have not set it right in the, let's see, in the, hasm.c. So the print, instruction print. Let's see, so we should encounter print. Alright, so we don't encounter print one time. So that is the problem. So we don't set, so that could be in the lexer then. Type print. That's type print. Alright, so we encounter it there. And then in here, we don't encounter it. So that's in the print token. So we're not doing that. Let's print the tokens. Next dot stack or stack size. Stack size. Right. Type no. So Alright, and that is print. So it does encounter it there. So it's creating it. But then we have one extra, and that's not good. Let's actually print the list. Alright, and this needs to be like that, I think. Alright, there we go. So the end, alright, yeah, so we go. Yeah, so this is all out of order. That is not right at all. Yeah. That's and print token token stack yeah. Alright. Alright, and let's not print the list. Alright, so the last one is print. And we have int. Alright, so the tokens are right. So the problem is again with the list. It gets it all out of order. So we have, alright, so it actually starts at the wrong index. So then it's out of bounds. Yeah. Yeah, so that should not be the first token. Then these subsequent ones are correct. Sir dot token stack 0 x equals 1. Root equals so why is the first one no? Yeah, so this is actually a problem. So we need to set the current value equal to that. Value equals 1. Actually, we can just set it equal to null entirely, I think. That might not work, actually. Oops, I did change the wrong one. Right, perhaps that is okay then. Alright, and then here, um, that's not right. Uh-huh. The initial value can be lexer dot token stack 0, and then next equals 1. Okay. Alright, so that looks better now. And can we print? Oops, that's not what I want. So print is not there. So we need to change this to not subtract 1. Okay. Now build that again. And there we go. Okay, so now if we emulate it. Okay. Finally working. So yeah, we had a lot of problems with that, but it should be working now. And now if we jump to 0, it should be infinite. I didn't need to rebuild it actually, I suppose. Alright, and we do have the jump. And it, okay, that's what I want to see. Alright, let me get rid of print statements. Let's see, where are they? So there's one in print in here, I think. There is not. It is in the lexer then. Yeah, not here, down here though. Or not. There's somewhere. Alright, so it's not in there. It's in TASM. Alright, let's see. So we don't need to print the list anymore. Okay. Alright, so there's one print. It might be in here actually. Yeah, right there. Okay. So now, alright, and yeah, still infinite loop. So can we push 0, push 0, push 0, and then print, and then yeah, hasm and time. Alright, yeah. So now let's try to get back to this. So we don't have comments still. But prev was prev and then per. Alright, so we want to not print. So we want to set prev equal to prev. So we want to index dupe 1 and then swap with 0 and then pop the top one to get rid of it. And previous number needs to equal current number, so we'll indupe 2. We can just dupe because it'll be at the top. And then we will index swap with 1. Yeah, and then pop again. And then we can do, let's see, so we need to add them all together. So next to 0, and do 1, add, and then swap. So that'll swap the top 2, and then you can print whatever that number is on the top. Alright, so let's try that. And then we don't want 0, 1, 2. Alright, so we want to jump to 3. So let me do that actually. Alright, so let's try that. I didn't need to do that, I suppose. Alright, and it did not work. Should not be in. So let's see. Did I mess something up? This needs to be index file. Okay. Time. Alright, so it did not print anything. And it didn't work. We don't want to jump to 0 though. Alright, so it's not working, it seems. If I get rid of those, I don't think... yeah, so it doesn't work. I think the program size is not right. Let's go, let's see, in the... here. We'll print stack machine. Oops. And let's see what happens. So yeah, it's just 0, 0, bunch of zeros. So, oh, because we need to start at 1 actually. So which one? Current number needs to be 1. Okay, so then we have a 1. And previous number should be. Okay, so I don't think it is parsing correctly again. So let's go into here and we'll print the list again. And we'll see what it is. That doesn't work. Alright. Test.test. Okay, so no, that seems to be right. Right here. Int is last one, then we have jump. Yeah, we have print. Is that twice? I think that is just a problem in the print list actually. Or it's in the print token. So that is over here. So why does it print it twice? Alright, well, so we have, yeah, so that's not it. Oh wait, no, there's more. Yeah, so we have push, and then 1, and push 0, and all the way on line 15. Yeah, so that seems to be right. Alright, so I think the problem is in our time then, perhaps. Because the length should not be 7, it should be longer. So, actually that is in the read from file, so that's in here. So, when we read from the file, we're not getting the correct length. So what if we do that? Yeah, it still doesn't work, and it's still not right. So I don't know what the length would be then. So it must not be reading properly. Alright, so alright, yeah, we are providing the file name. Okay, well, so I'm going to have to be done for today. So I will push this. It's not working entirely yet, but I can push it. Actually, let me modify the git ignore. Thanks out here. Alright, gotta close all these. Alright, and hit ignore. So what do we need to ignore? So we need TASM time, and then we also want the generated ones, which those should be blocked already. So I think it's just time that we need. Alright, so we can do that. Yeah. So so we implemented fully implemented parsing and bytecode generation. Okay. Needs work because it doesn't work. I suppose that's how you could put it. But some things do work. So yeah, I will look into that. I'm not sure exactly what's wrong, but I will figure it out before the next stream. Alright, but it should be up there now. Yes. Alright, so you can take a look at it if you want to, or whatever. There it is, Tim. Yeah, so thank you for watching, and I will see you next time. Goodbye.